Um, Hi, we are students from the Claremont colleges, and we did a little bit of investigation into commercial medical predictions using graphical networks. But this time we decided to implement new database called Neo4j in our project. So our objectives for this project was to first investigate commercial practices, and that includes improve machine learning development process, and also using Docker to automate standing up our environment. And so examples of our environments include Neo4j, Jupyter, and also Docker, as well as apply Neo4j tools to store our data sets and implement graph analytics utilizing commercial products.
Yeah, so an important topic is what is graph data science here? So for those who don't know much about graph data science is a science-driven approach to gain knowledge from the relationships and structures in data, typically to power prediction. So here on the left in the graph, we can see graph data science can be related to graph algorithms, graph queries, and graph visualization. And in general, data scientists, they use relationships to answer those questions. And here is like why we use graph data science. And the next is when speaking about graph algorithms, we are typically looking for a global pattern and the structure. So the input to the algorithm is usually the whole graph, and the output can be an enriched graph or some aggregate value such as a score. So we categorize such processing as graph global, and it implies processing a graph structure using computational algorithms. And this approach sheds light on the overall nature of a network through its connections. So here on the graph, on the right is the spectrum of the right is the global computation. So you're learning the overall structure of a network, updating data and predicting. But on the left is the local pattern. So you know what you're looking for, and you try to make a decision. So specifically speaking, in Neo4j graph data science library, in the algorithms, they include link prediction, which is those algorithms used to determine the closeness of pairs of nodes. And the second one is node embeddings, which is the computer vector representations of nodes in a graph, like including GraphSage and Node2Vec. So node embedding algorithms usually transform the topology and features of your graph into fixed length vectors that uniquely represent each node. So graph embeddings are powerful because they preserve key features while reducing dimensionality in a way that can be decoded. So embeddings capture the complexity and structure of a graph and transform it for use in various machine learning tasks. And the third one here is node classification. So it uses machine learning to predict the classification of nodes. One more thing, GraphSage, we want to mention here is GraphSage is an inductive algorithm for computing node embeddings. So GraphSage is using node feature information to generate node embeddings on unseen nodes or graphs. So instead of training individual embeddings for each node, the algorithm learns a function that generates embeddings by sampling and aggregating features from a node's local neighborhood. And GraphSage is an important part of the example project that we are demoing here using Neo4j. Yeah, so why should we care about using a graphical database? So the first reason is in order to leverage data relationships. So a lot of organizations, they need a database technology that stores relationship information as a first class entity. So that technology is called a graph database. And also, a graph database is an online database management system with create, read, update, and delete operations working on a graph data model. Unlike other databases, relationships take first priority in graph databases. So this means that your application doesn't have to infer data connections using things like foreign keys or out-of-band processing, such as MapReduce. And today's enterprise organizations, a lot of them are using graph database technology in a diversity of ways. For example, like fraud detection, the master data management, network and IT operations. So this is why graphical database is important and convenient to use for a large amount of data. And next is the Neo4j advantages. So Neo4j has a lot of advantages, and the two of them is it provides a lot of more convenience in storing and analyzing data. And it also provides easy access to storing information just in one place at a time. This is the importance of utilizing Neo4j in storing diagnostic data like medications and surgical procedures. And here for this current video, we used an example using Neo4j project, and the contribution is like we made the graph database, which is built for industrial use, and therefore it can help to leverage it to other technology.
Yeah, so up until this point, we've heard about Neo4j and kind of like the importance of graphical data science. So cool. So we're bought in. How do we go from there? So for our implementation and what we're going to showcase today is a combination of a couple different data science tools, such as Jupyter Notebooks, and leveraging Neo4j, all comprised in Docker containers, so that you can just press one command, it spins up your database, it spins up your coding environment, and then you can just start going to town. So, I mentioned Docker before. So as a slight tangent, one way that we can help optimize our data science process is to develop everything in Docker containers. And you might be asking, well, why should I care about Docker? Or specifically, how does that relate to this talk right now? And the way that it is so our Jupyter Notebook environment has a lot of different Python dependencies. For example, it has PyTorch and it has PyTorch geometric. And a lot of those different packages require a specific type of environment, different versioning, and that kind of stuff for like your host machine. So it can be a little tricky to set up, and especially if you have multiple developers, it can be very tricky. So one thing that we've done is to kind of reduce all that complexity, really take that away. We've automated the building of our environment, installing all of our packages and deploying our Jupyter Notebooks in Docker containers. And then additionally also deploying Neo4j in tandem and linking them up on the same internal network. So works out really nice. This is just our Docker Compose YAML file. It's basically just the configuration saying this is one container that we're spinning up, and this is our separate container for Neo4j. So yeah, using Docker, So again, so it automates standing up our environment. So for those of you that are familiar with the scripting language like Bash, this will seem very familiar in a Linux environment. So what we're doing is we're making directories, we're copying the project into those directories that we made. We're installing all of our Python packages. If you're familiar with installing, with pip, this should be very familiar. And then we're launching our Jupyter Notebook on port 8888, and you'll see that later. And this is just a console output from running Docker. So
Yeah, just to get you started on using Docker, once you have your terminal open, mostly what I would do, or essentially what I would do from here, is to type in the command docker compose app, docker space compose app, and then from there it would take you to, this is mainly to get your the images in a container running. And so from there, the next thing that I would do after this is type in docker compose app. And this is also mainly to get you get you started on using Docker. And then you can go into the next slide. So up here, this is how the code looks like, or this is how it looks like on Docker. So once you have your libraries imported in Docker here, the rest of it, it's just like going through the code and also making sure that all of the libraries that you need to run your code in Docker is it's available. And so as we can see here from our code example, we are essentially just printing out from here, we are printing out the initial rows in our code. And as we can see here, from the output, you can see the various event IDs. We can also see the visibility, which is whether or not it's giving us whether or not it's true. And then also timestamp and the locations and longitude and latitude as well. And so that's how the code, if this would look like, or this is how it looks like when you run your code up in Jupyter. Yeah.
Okay, so we kind of have touched on graphical databases with Neo4j, and we've talked about data science development using in Jupyter notebooks using all with underlying Docker containers. So cool. So now let's kind of jump into some of the code to see how this plays out. So, we're giving a live demo, so nothing could go wrong. So as my colleague just mentioned, all you do to start this up is you cd into the directory that you want to, that has the code. So you do docker compose up, and then you'll start to see it pulling different layers. So here it's pulling Neo4j down from Docker Hub. So this should hopefully be very quick. But so effectively, while that's running, I'll show a little bit of the background of the Python code. So Neo4j uses a query language called Cypher, similar to SQL, but it's specific to Neo4j. So because it's a graphical database, relationships, the edges along each node are baked into the structure of how we query and how we put data into the database. So an easy way to kind of get started with this is to use a Python package called wait, where did I do this? Neo model, sorry. So Neo model has kind of abstracted some of the Cypher query languages, or the Cypher queries, into some easy structures. So what we can do is we can create a base model that has our properties and defining kind of like, okay, we have a unique ID, we have a string property, we have a date time, right? And then once we have our data model that is going to be loaded into the database, then we have our controlling classes in Python that can load in a CSV file, create relationships between the different points and actually set those edges to create the graph. So here, it finally pulled the image from Docker Hub for Neo4j. So now we have our database running, and now we have Jupyter running, and all we had to do is just run that one command. So as we mentioned before, we're executing our Jupyter notebook on port 8888. So if I go to, and similarly, if you look at Neo4j, that's on 7474. So if we open up a browser, we can go to localhost 8888. It brings up Jupyter Notebook, and we have our project. Again, so this is all running in a Linux environment, even though my computer is Windows. So that's kind of the beauty of developing in Docker. And so here we can go in and say, we can execute our code. We can load our CSV. This data controller class, this Neo4j drivers, is actually something that's included as a package that we wrote. So this code right here is this bluefin whales. So the data set is migratory species data, specifically blue and fin whales. So there's a timestamp and a geolocation, a latitude, longitude point. And so here we're able to code as we would normally, like in a class or object-oriented way. And then we're also able to execute our code on a line-by-line basis, kind of leveraging the best of both worlds of like straight Python development and Neo4j kind of tinkering. So after we've loaded all of our data, then we can look at our database, localhost. Localhost is just syntactic sugar for your local IP address. So here we have our database. Oh, that doesn't want to perform apparently. Okay. Well, yeah, effectively, it ends up looking like this. So each of our nodes get loaded in, and each of these edges, the red ones are time relationships and the blue ones are spatial relationships. So as we're entering data into the point, we're creating structure to the graph, which is great at scale. So it's a living kind of you're developing a shape of the data. So you're providing context to this cluster as opposed to this cluster and its neighboring nodes. So yeah, that is our presentation, and here we are.